Good morning, students. Can you hear me? Can you see the screen? I have to do that check before we start.
Yes.
All right, good. All right, so you know we're just going to be revising some matrices today. I've decided not to bother to do the classwork question because it was so well done in the class, right? So I don't think I need to go back over that question. I think it'd be a waste of time, really. So I'm just gonna practice some of the questions that I sent in the group. Alright, and this is just a revision session. Shouldn't be too long today because it's a very easy topic. Starting a new topic tomorrow, transformation. And you'll see in that topic that you need to know matrices in order to do transformation. Alright, we'll see that from tomorrow. It's gonna be fun. Alright, so this first question here is on the May-June 2019 exam paper, and it is question 10 on that paper. And first part wants us to work out this product, and if you notice there are some unknown quantities in there, so it means that those unknown quantities will be in the result. And you must know by now that when you multiply a 2 by 2 matrix and a column matrix, the result is going to be a column matrix, a 2 by 1 matrix. So this is going to be equal to a column matrix with 2 values. Let me use it ready for that. 2 values, one here, one here. And we're multiplying these two matrices. Remember, we multiply the rows of the first matrix by the one column of the second matrix. So to show that we're using these two rows in this multiplication, I usually put a line across here. Alright? And then we're multiplying those two rows, these two rows, with this one column. Alright. So this first value here that we want is positioned in the first row and the first column, or the one column. So to get it, we have to multiply this first row by this one column. And you multiply them again the same way as before. First element in the row times the first element in the column, plus second element in the row times the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. So it's negative 1 times k and 3 times 5. The negative 1 times k is a negative k, and the 3 times 5 is 15. So negative k plus 15 is that first value. Then the second value here is positioned in the second row and the one column. So to get it, you have to multiply this second row by this one column. And it's again first element in the row times the first element in the column, plus second element in the row times second element in the column. So it's first element times first element, second element times second element. 4 times k and h times 5. 4 times k and h times 5. So the 4 times k is 4k, and the h times 5 is 5h. So that is your result. That's the answer right there for your matrix. But okay with that? But good with that? Hello? It's a class.
Yes.
You have to answer. Alright, good. Then down here now says, hence, find the value h and k, find the values of h and k to satisfy this equation. And remember now that this part of it is what we just found up here. That is it now. That's what we just found up here. Right? And they're telling us that it is equal to 0. And so if that is the case, it means that this resulting matrix is 0. We can later just copy this down. Because the same product that we have down here, it's now equal to 0. Is equal to the 0 column matrix. Equals 0, 0. It means that this value is 0 and this value is 0. That's what it means. So we can write that minus k plus 15, that's this one, is equal to the 0 here. To make k the subject, we can take this negative k, bring it over here, it becomes a positive k, equals 15. We can turn this around and write k equals 15. So that's one value for k. And then this part now is equal to 0 as well. So we can say and the 4k plus 5h is equal to 0. Remember that the k is 15, so we can put 15 right here for the k. So then this becomes 4 times 15 plus 5h equals 0. And to get rid of this 5, we can just divide through by 5. No, this is not the only way to do it, but we can divide through by 5. So divide each term by 5. To cancel away this 5 and leave h right here. So we divide through by 5. We can apply the 5 onto this 3 right here, onto this 15 and get 3. Then this one cancels with this one, and this is still 0. So we're gonna get 4 times 3. 4 times 3 is 12, plus this becomes h is equal to 0. Take this 12 and bring it over this side. H is equal to negative 12. That is the answer right there. K is 15, H is negative 12. But okay with that?
Sure.
With that? Alright, let's continue. The next question down here says we have to use a matrix method to solve this pure simultaneous equations. So to use a matrix method, a standard method, guys, there's nothing about it, right? It's the same way that it is done all the time. All you have to do is ensure that it is set out in the right way. What is the right way? On the two equations, you want the x value first and the y value second and a constant over here. X value first, y value second, and a constant over there, which is good. So it means that this pair of simultaneous equations can be written as a product of two matrices, a 2 by 2 and a column matrix. It's going to have xy in the column matrix. That's why you have to have x followed by a y, x followed by a y on the two equations. And that is going to be equal to a matrix with these values, 5 and the 13, a column matrix. Then now to populate this 2 by 2 matrix, you're using the coefficients of the x and the y from those two equations. So on the top line, the coefficients of the x and the y is 3 and 2. No, wait, 2 and 3, 2 and 3. So you put the 2 and the 3. The coefficients of the x and the y on the second line is negative 5 and a 1. When there's no number in front of the y, coefficient is 1. So negative 5 and 1. Negative 5 and 1. That's a matrices equation, and we are trying to make this the subject. So it means that this goes over in front as the inverse. That's how it is transposed. Let's write it like this. So it's xy becomes equal to the inverse of this matrix, 2, 3, minus 5, 1. I'm putting the minus 1 on it because it is the inverse. Put on in the red. So the inverse of this matrix goes on the front of that side, multiplied by this matrix beside it. Right, so that is a 5, 13 beside it. So we need to calculate this now, right? And then that we get the value of x and y. But first we have to work out what the inverse matrix of that is, which is 1 over the determinant times the adjoint. Remember, inverse is equal to 1 over the determinant times the adjoint matrix. Right, and we're talking about this matrix, so we want the inverse of it right here. So this then becomes equal to 1 over the determinant. Now, how do we get the determinant? How do we get the determinant? Determinant is the first diagonal product minus the second diagonal product. The first diagonal product is 2 times 1, which is 2. Minus the second diagonal product is 3 times negative 5. That's a negative 15. So this minus minus here becomes a plus, and it will be 2 plus 50, which is 17. Let's write the determinant in red. So 17 is the determinant under here. then you have to multiply that now by the adjoint matrix. The adjoint of this matrix. How do we get the adjoint? The elements on the first diagonal are switched around. These two elements, we switch them around on that first diagonal, or the leading diagonal. Switch them around. So 2, 1 down here becomes 1, 2 down here. Then the elements on the second diagonal, or the trailing diagonal, or the secondary diagonal, or the following diagonal, which is this diagonal here, those two values. You leave them where they are and change the sign. So this 3 up here stays where it is but becomes a -3. And this -5 stays where it is but becomes a +5. And all of this is the inverse matrix so far. We now have to be multiplying by this matrix 513. So we have to multiply that now by 513. And what you know what do in a case like this? Right? This is xy still, and xy equals that. We normally work out this part of it first. Leave the 1/17 for last. Alright? So you multiply these two matrices just the same as we did up here, the first question, up the top, right? So I'm multiplying the 2 rows by the 1 column. Alright, so we're going to work out, as I said, this part of it first before we divide by the 17. So this is going to become equal to 1/17 times a column matrix with 2 values. That's what I'm going to get when I multiply these two. And so again, it is first element times first element and second element times second element for this first value. Just did it a while ago to up the top. Alright, same process. So it becomes 1 times 5, which is 5, and -3 times 13, that's -39. Then this second value is on the second row and the 1 column. So to get it, to multiply this second row by this 1 column. First element times first element, second element times second element. 5 times 5 and 2 times 13. 5 times 5, 2 times 13. So the 5 times 5 is 25, and the 2 times 13 is 26. Shift this bracket over a bit. So it becomes 1/17 bracket. This becomes -34. And this one becomes 51. 25 and 26 is 51. And I like this because these numbers are perfect multiples of 17. So when you divide each of them by the 17, -34 divided by 17 is -2. And 51 divided by 17 is 3. So it's xy that is equal to that thing. It means then that the x is equal to -2 and the y is equal to 3. So that is the answer right there. That is that question. So almost every one of these questions done the same way, guys. Simultaneous equations using a matrices method. All done the same way. But alright with that, I think this finishes.
Yes, sir.
This is a nice full matrices question finish. Alright, I think it was the next another question I gave you to do was, let me look back at it. Give it 29. I think I gave it January 2025 as well. Let me see. Alright, let me see this one. So I have it here and it is solved now. I don't remember if I solved it for you. No, the session let me look. Chances I solved it for you already, but no problem. One math equals beta math. So let's do it again. I don't remember if we did it before. I don't remember, I'm not sure. But I'm just gonna work it out now again still. So let's erase it. And let's do it over again. If that is the case. Alright. Doesn't hurt. More maths equals better maths. Alright, so let's look at it. Simple matrices question. First part says, determine the value of the unknowns in each of the matrices equation below. So these are your unknowns. Alright, and that's a plus. It means that you're adding these two matrices and this is the result. It means then that this value plus this value is equal to this value. So we can set that up. 4 plus x equals negative 3. Take the 4 and bring it over this side. We end up getting x equals negative 3 minus 4 as x equals negative 7. And then this y is the sum of this and this. You can set that up as well. Which is negative 2 plus 8 is equal to the y. So 8 minus 2 is 6. So 6 equals y. We can turn it around and write that is y is equal to 6. That is the x and the y in this question. Very easy, very easy. I don't want to lose marks and something like this. Alright. This is in January 2025. So you see, I'm setting questions like this, right? Now this one now once again us to find the value for A and C. And this time it is a product that is equal to this matrix. So we're gonna do this is set up like an equality of matrices. And these are the two values that you want to get this value. Right? It's the first column, so it has to be something on the first column. So we can say, okay, let's use this negative 10. What gives us that negative 10? Negative 10 is the product of this row and this column. Negative 10 is the product of that row and that column. So we can set up an equation based on that. Alright, so let's do it. So it is the 5 negative 3 times the AC, that is equal to negative 10. Alright, so it's 5 times A and negative 3 times C, that is equal to negative 10. So the 5 times A is 5A, negative 3 times C is negative 3C. That's all equal to negative 10. So that's one equation. Alright. Then now, this value here, 17, is the product of second row and the one column. So we can set that up again. So it's going to be that 2, 3 times the matrix AC, the column AC, is equal to that 17 over there. So it's 2 times A and 3 times C, that's equal to 17. So it's 2A plus 3C, that is equal to the 17. So this equation has a minus 3C, this equation has a plus 3C. So what we can do is just add them. If you add them, you'll eliminate these two values. So we're going to add these two equations. We're going to add them. So add up everything on the left side. Add up everything on the left side. That's going to give us 7A, because the 3C and the minus 3C cancel each other. So getting 7A. Equals, add up the right side now, the negative 10 and the 17. Negative 10 and 17, if you add them, it's really 17 minus 10, that is 7. So if 7A equals 7, this means that the A is equal to 1. That is it. Easy question. Easy question. What are to that? What good?
Yes, sir.
Alright, beautiful. Let's look at the next one there. It could be on this list if I have on the screen. The next one would be 2021. Let's look at this one. Alright, let's see what this one says. Down to the back. Alright. Here we go. This is it. Look at what is happening here now. This question is asking us to multiply a 2 by 2 matrix and a 2 by 3 matrix. This is a 2 by 3 matrix that has 2 rows and 3 columns. So I always call the number of rows first when you're stating the size of a matrix or the order of a matrix. So what are we supposed to get? What size matrix are we supposed to? Let's work it out. So this is a 2 by 2. This is a 2 by 2 multiplied by a 2 by 3. Since the number of columns here in the first matrix is equal to the number of rows here in the second matrix, the multiplication is possible, and the resulting matrix will take the number of rows from the first matrix, that's this, together with the number of columns in the second matrix. So the resulting matrix for this is of the order 2 by 3. That's 2 rows and 3 columns. So we can set up for that. So this product is going to be equal to a 2 by 2, 2 by 3 matrix. And we can set up like this. So it's going to have 2 rows but 3 columns. So same process again. Let me move this out the way so it's a bit clearer for you what we have to do. So this value right here, right now, is in the first row, first column. And again, you always take the rows from the first matrix and the column that you're using from the second matrix. So this first matrix has 2 rows. This one has 3 columns. So I'm putting a line down here to show that I'm using these 3 columns. So but back to this. It's in the first row and the first column. So to get it, you multiply this first row by this first column. You multiply them the same way again. First element times first element, second element times second element. First element in the row times the first element in the column, plus second element in the row times the second element in the column. So it's 5 times 2 is 10, and 4 times 0 is 0. And then this second value right here is positioned in the first row and the second column. So to get it, to multiply this first row by the second column. That's what we're using. So it's first element times first element, second element times second element. First element times first element, second element times second element. So that becomes 5 times 1 and 4 times 3. So 5 times 1 is 5 and 4 times 3 is 12. And the last value out here is positioned in the first row, third column. So to get it, we're using this first row with this third column. Again, it's first element times first element, second element times second element. First element times first element, second element times second element. So it's 5 times negative 4 is negative 20, and 4 times 6 is 24. Then we come to this value down here now. This one is positioned in the second row but the first column. So to get it, to multiply this second row by this first column. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. So this one now is negative 3 times 2. It's first element times first element. Negative 2 times 0. So negative 3 times 2 is negative 6. And negative 2 times 0 is 0. And this second value is positioned in the second row, second column. So to get it to multiply this second row by the second column. So it's first element times first element, second element times second element. First element times first element, second element times second element. Minus 3 times 1 is negative 3. And negative 2 times 3 is negative 6. The last value out here is positioned in the second row, third column. So to get it to multiply this second row by this third column. Ready again. So that becomes negative 3 times negative 4 is positive 12. Negative 2 times 6 is positive 12. Let's go again. So multiplying this row by this column to get this last value. So it's first element times first element, second element. Come on, Mr. Shaw. Second element, first element times first element, second element by second element. So it's negative 3 times negative 12. Negative 4 is positive 12 here. And then it's negative 2 times 6, that's negative 12. That value is going to come out to be 0. We can write what the final answer is now. This works out to be 10. This works out to be 17. This works out to be 4. 24 minus 20 is 4. This works out to be 6, negative 6. This works out to be negative 9. And this works out to be 0. That's a matrix. The product. But I write that. But good?
Sure.
Alright. Let's look at the next one. Alright. Next part says, state why the two matrices are conformable for the multiplication. It's the same thing that we wrote up here a while ago. This thing. They are conformable. When the number of columns in the first matrix equal the number of rows in the second matrix. This is it. Number of columns in the first matrix here is equal to the number of rows in the second matrix. So the reason why it is conformable is this. All right, here, so the number of columns in the first matrix is equal to the number of columns, so number of rows, sorry, so the number of columns in the first matrix is equal to the number of rows in the second matrix. That's why it is possible. But understand that? But you good with that?
Yes, sir.
Alright. That is why. So you see, they ask these things on exam paper, right? So see for yourself. This question down here wants us to determine the inverse of this matrix. And the inverse of this matrix is 1 over the determinant times the adjoint. Let's just work it out right here. 1 over the determinant is this diagonal product minus this diagonal product. Be careful with those negative signs. So this diagonal product is 5 times negative 2, that's negative 10, minus this diagonal product is 4 times negative 3, that's a negative 12. That's negative 12 is the second diagonal product. And so this minus minus becomes a plus. So it becomes plus 12 minus 10. 12 minus 10 is 2. So the determinant is actually 2. You put 2 on here. Alright? And then now you multiply that by the adjoint matrix of this. Or you get the adjoint again. Interchange the elements on the first diagonal. Don't change the sign, just interchange them alone. So the negative 2 goes up here, and the 5 goes down here. Then the elements on the second diagonal, they stay where they are, but you change the sign. So this positive 4 becomes negative 4, this negative 3 becomes positive 3. And basically that's your answer, right? Because you're dividing each of these now by this 2, the determinant. So we can write the final answer right here. Let's put it right here. So negative 2 divided by 2 is negative 1. Negative 4 divided by 2 is negative 2. And then 3 divided by 2 is 1.5. And then 5 divided by 2 is 2.5. That's the answer right there. But alright with that calculation?
Yes, sir.
But okay? Yes, I said?
Yes, sir.
Alright. So this is a very easy topic. Alright, let's see what the next paper is. Today's going to be a short session. I just want us to do some revisions. Always good to revise and practice. Alright? Always good to just revise and practice. Alright, so I did this one already. Did I do it in the class? I don't remember doing it for you guys, but I did it already. Anybody can remind me if I did this one in the class? If I did this one in the session? You did a session the other day I did this one? I see it you're done, but I don't mean that. Huh? I did it the other day, right? Somebody answer now?
No.
Not hearing you, not hearing you. Alright, let's do it again then. Because nobody talking. Nobody's talking. Did we do this question the other day? Yes or no?
Yes, sir, man. I said last week class.
Did it last week? Alright, so I can find another one and do it. Because I'm going to do this one. I don't remember. Last week was a very hectic week for me, so I think we did last week. And I would have shared the video as well. Alright, so we'll find another one. As I know today is going to be a short session. As the week kind of get messed up, so the normal sequence of our activities kind of change. Alright, so we can find another paper for us to do. Something different. 2024. Let me see if we did this one. 2025. So like we did this one as well. So the little current. So the video for these would be in the group. Alright, if we did them last week. And the video for them is in the group. Well, let me see. Find some other paper. 2021, January, let's try January 2021 and see. Alright, so let's see. We didn't do any matrices on this one, or this one was a transformation. Let me see. So guys, if you're not sure and you want to see the solution for those questions, you can go and watch the video. I would have sent the video to the group. Alright. So usually the last question of the paper. Matrices are transformation. Alright, so this one now. Alright, here's one that we can do. Well, part B is transformation, but part A is straight matrices. We can do this one now. This is 2024. No, 2021 January. So this one gives us his matrix. And that's W. Same W here. And it says, determine the matrix L if W plus L equals that null matrix. This is a null matrix now, the Z matrix. Right? So kind of easy. We want to find the matrix L. Kind of easy. So if you have 3, 6 minus 2, 5, that's a W. You're adding another matrix L. Let's call that matrix A, B, C, D. This representation. And that's equal to 0, 0, 0, 0. It's quite obvious that these values are inverse of addition of each other. In other words, if this is 3, you have to subtract 3 to get 0. So the A equals negative 3, obviously, right? This question I need a calculation, you know. Right? So the A equals negative 3. And then now the inverse of addition for this value is negative 6. So if you're adding these two values and getting 0, then the B has to be negative 6. So the B equals negative 6. And then now if this is negative 2, we're going to add 2 to get 0. So the C equals 2. So the C equals 2. And if 5 and D is 0, then the D has to be negative 5. That is it. So this and negative 3 is 0, correct? 6 minus 6 is 0, correct? Negative 2 and 2 is 0, correct? 5 and minus 5 is 0, correct? Sorry, 5, yeah, because it is negative 5. Those are the correct answers. What after that? Easy question. What good? What okay?
Yes, sir.
Alright, good. Let's look at this one. Now, they must find the vector P. What does that mean here? W times P equals the identity matrix. That's the identity matrix, you know. And you must know that the product of two matrices which are inverses of each other is the identity matrix. This is the identity matrix. And we know that W times W to the minus 1 is going to be equal to the identity matrix. So you see this P in this position right here is the inverse of W. So we just need to calculate the inverse of W, and we have the P. That's all this question is testing your knowledge of. So see, that's what I tell you. You have to know about this identity matrix. So we know that W becomes P to the minus 1. What is the P? Let's write the P over here. So again, let me write it here. So the P is, what is the P? The P is, oh, it's the other way around. Sorry, is a W and no. Sorry, it's a W and no. So it's the other way around. So it's P times P to the minus 1. P times, which I want to know the W. Right, so W times W to the minus 1. Alright, W times W to the minus 1 is the P we're trying to find. My mistake, right? So it is W times W to the minus 1 is equal to I. So this P is W to the minus 1. So we do that other way around. So the P is W to the minus 1. So the P equals W to the minus 1. And this is the W that we were given. The W we were given. W is 3, 6 minus 2, 5. 3, 6 minus 2, 5. Alright, so this equals 3, 6 minus 2, 5 to the minus 1, meaning the inverse. So it's 1 over the determinant. It's 1 over the determinant. Remember, that's what I thought over here. W to the minus 1 is 1 over the determinant of W times the adjoint of W. Right? So, what's the determinant of W coming under here? It is this product minus this product. So this product, first diagonal product is 3, 5, 15 minus, and this diagonal product is negative 12. Negative 2 times 6 is negative 12. So this is really a plus. 15 plus 12 is 27, so under here is really 27. And then multiply that now by the adjoint matrix of W. And the adjoint is obtained by interchanging these two on first diagonal. Switch them around. So you get 5, 3. Then leave these two where they are and you change sign. So this 6 becomes negative 6 where it is. And this negative 2 becomes 2 where it is. So the result for this is you're dividing each of these values by this 27. Alright, so you're gonna get 5 over 27, negative 6 over 27. You're gonna get 2 over 27. You're gonna get 3 over 27. And this is your inverse matrix of W. Because if the product of these two matrices is equal I, then it means that they are inverses of each other. So P is inverse of W and W is inverse of P. What okay with that? What good?
Yes,
Yes, sir.
Yes,
sir.
sir.
Yes, and matrices no. Down here is transformation, guys, right? So we're gonna deal with this starting tomorrow, transformation. But that finishes that paper, 2021. Let me go down and see if I have any more that we can maybe look at. 2021 with May 2024. While ago. Let's see. January 2024. Let me see. Can we try this one? Or 2014. January 2014. Let's see the matrices on this. Alright, so we do this question another time. Okay, there's some transformation too, right? Down here. So we do this question another time. That's not it now. Has some transformation on it. So I'm gonna do that one now. When we do transformation, we will do this one. I think it's because paper available there. January 2018. That's what we just did. Or the 2018. Yeah, let's do January 2018. Let's try this 2022. Let's try 2022. Let's try this one. It's just a revision and practice, guys. Again, this is a transformation. So one of this is transformation. This part is matrices though. It says 2 by 2 matrix C is defined by the scalar constant in terms of scalar constant by this. So this is the matrix C. Let's say determine the value of K given that C is singular. Remember, if C is singular, it means that it has no inverse. Let me get that with it. Has no inverse. Has no inverse. Because the determinant of C is equal to 0. When determinant is equal to 0, it means that this diagonal product is equal to this diagonal product. Two diagonal products equal. So you can also say AD as A times D is equal to BC as B times C. So this diagonal product AD is 3 times 4 is equal to this diagonal product, which is K times 6. Alright, now this is 12. So for this to be 12, the K has to be 2. So the K equals 2. Yes? Nah. That is it. Alright. And this is a matrices in the first part of the paper, which I doubt. doubt it a lot. I doubt it. None there. Alright, let's see the next paper we can do. Next paper that's there. This is 2022. January 2023. Let's try this one. Let's try this one. Alright, here's one. It's a nice one we could do. Not gonna keep it very long today, guys, because this thing really very easy, right? Really easy topic. It says 3 matrices Q, R, and S are these. Q, R, and S. Question says, explain why the matrix product QS is not possible. That's Q times S. Why is it not possible? Because it's not conformable. We have to explain, right? So let's see what it would be. So the QS would be a 2 by 2. Right over here. Right up here. Zoom in. Depend on the thinner. And it up here. Right. So QS would be a 2 by 2. That's what the Q is. Times a 3 rows by 2, comma 3 by 2. Now, because the number of columns in the first matrix is 2, but the number of rows in the second matrix is 3, they are not equal. That's why it is not possible. For it to be possible, they have to be equal. The number of columns in the first matrix must equal the number of rows in the second matrix. In that case, they are said to be conformable. These two are not. You have to write that. The number of columns, writing why it's not possible. Number of columns and yes. In the first matrix Q, I'm going to write in Q, is not equal to the number of rows in the second matrix. In this case, second matrix is S. That's the answer right there for the 1 mark. And we want the 1 mark. We want it. Next one says, state the order of the matrix product S times R. Let's set it up. So S we say is a 3 by 2 matrix. S times R is a 3 by 2. And the R is a 2 by 2. Alright, so this is possible because the number of columns here match the number of rows here. And the result is going to take the number of rows on the first matrix against the number of rows in the second matrix. That's the result. And so they just say state it, right? They don't want an explanation, just state it. So state. So SR is 3 by 2. That's it. That's order. Order of SR. That's why it's called this way. Order of SR is this thing. Alright, anything else? It says calculate the matrix product QR. Q times R. So multiplying these two. I'm write them up here and copy it down. So we're multiplying QR, which becomes the product of Q 2 minus 1 4 3 times R, which is 1 6 minus 5 4. So I'm multiplying these two. usual, it's going to give us a big 2 by 2 matrix with 4 values, and to get those 4 values, you have to know the right row and right column to multiply. You take the rows of the first matrix, so I put a line across here to remind me of that. And you take the columns of the second matrix, I put a line down here to remind me of that. And this first value is the first row, first column value. So using this first row times this first column. Same thing again. First element times first element. Second element times second element. So it's 2 times 1 and minus 1 times minus 5. 2 times 1 is 2. Minus 1 times minus 5 is a positive 5. And the value over here is the first row, second column value. So using this first row with this second column to get it. And again, it's first element times first element, second element times second element. 2 times 6 minus 1 times 4. 2 times 6 is 12. Minus 1 times 4 is minus 4. Then the value down here is positioned in the second row, first column. So to get it, to multiply this second row by this first column. Alright? And then we are gonna go first element in the row and the first element in the column. Second element in the row and the second element in the column. So it is 4 times 1 is 4. And 3 times negative 12 is negative 15. Then the value down here is positioned in the second row, second column. So to get it, to multiply this second row with this second column. So it's 4 times 3, 4 times 6, sorry, 3 times negative, 3 times 4. Alright, so then some nice figures. 4 times 6 is 24. And 3 times 12, 3 times 4 is 12. And we can write the final result for this one equals, this becomes 7, this becomes 8, this becomes negative 11, and this becomes 36. That's the answer. But okay with that? Easy stuff. But alright?
Yes, sir.
Sir.
Alright. Then this one now, it says, given that this is the matrix A, and determine the value of x when the determinant, this means the determinant is 5. That's what this is saying, the determinant is 5. So to find the value of x, we need to write an expression for the determinant and put it equal to 5. And the determinant will be this product first, which is 4 times x, which is 4x, minus this product is actually a positive 7, because it's negative 7 times negative 1, it's positive 7. I put that equal 5. You take this negative 7, bring it over here, and add to the 5, we're going to get 12. So you're going to get 4x equals 12. And divide by this 4, you're going to get x equals 3. And that is the answer right there. Alright, next part is our vectors. Alright, so we're going about 45 minutes. Maybe one more question. And we'll call it a day. So today is a short session. Short session. Alright, so at least we get some revision in. So you see how the questions are on these papers. You see that what we're doing in class, the same thing they're testing on actual papers, right? So you really should have no fear of these things. You can do them in the class, you can do them in the exam when the time comes for your exam. Alright, let's see which one we can do next. Which one is there? January 28. Let's try 2017 January already. Let me see if we try 2017 January up here. 2017 January. Don't look so. Alright, we try January 2017. January 2017. Let's do this one. It's okay. We call it a D. Alright, January 2017. Matrices. Let's see if that matrices there. Right. Was a transformation. It's more transformation than a matrices. Yeah, I'm not doing this one there. Osh. Not doing this one. It's more transformation than matrices. So we can continue looking for one more. Let's find one more to do. Let's try 2015. That's what comes up on 2015. 2015. Dot 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 dot. Dot 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 dot. Let's see. Functions. It's usually at the back. Alright. Yes, we can do this one and then call it again. Yes. Alright, we need part A. And then we call it a D. Of this question. At least this one testing commutative, right? See? Commutative, something we spoke about in the class as well. Commutative. Alright, so at least we get into touch a little commutative. So we'll see, they like to talk about, they like to ask question about whether the matrix multiplication is conformable or not. They also like to talk about the non-commutative nature of the multiplication of matrices. Alright, so we'll see. So actually I gave an example in the class similar to this one that we're doing now. So you see, we'd actually asked to calculate the product A and B first. Right? Those two, they ask for that first. And then down here they say show that the matrix product AB is not commutative. That is, AB is not equal to BA. See, they have a question similar to this in the class. So let me show you that it's exactly what I told you. They ask for one product first. That's A times B. So if you work out the product of these two first fully. Alright, so the AB would be 1123 times 1201, and as always you're multiplying the rows of the first matrix by the columns of the second matrix. Let's go with it again one more time. It's a big 2 by 2 matrix with 4 values. Let's run through this one a little bit quicker now. So the first value here is this first row times this first column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 1 times 1 is 1, 1 times 0 is 0. Then the value out here is positioned first row, second column. So I multiply this first row by this second column to get it. So it's 1 times 2 and 1 times 1. 1 times 2, 1 times 1. So 1 times 2 is 2 plus 1 times 1 is 1. You can put the answer beside it from now on. Equals. This first value is a 1. This first value is a 3. This value down here now, it is in red. This value down here is second row, first column. So we're getting second row, first column. First element times first element, second element times second element. First element times first element, second element times second element. 2 times 1 and 3 times 0. So 2 times 1 is 2 and 3 times 0 is 0. So the value over here is a 2. The last one now, guys, it is this value out here, the second row, second column. So to get it, it's this second row and this second column. Second row, second column. So it's 2 times 2 and 1 times 3 times 1. 2 times 2 plus 1. Another one is 3. 3 times 1 is 3. Alright, let's put the value. So it's 2 times 2 is 4. And 3 times 1 is 3. Alright, so last value there, that's 7. 1, 3, 7. That is it. Alright, and that's what AB is. And down here, so now it says show that the matrix product AB is not commutative. Not commutative means that AB is not equal to BA. So because we have AB already, we can start working on BA. So BA would have been this one in front, right? So it will be 1, 2, 0, 1 times A now, which is 1, 1, 2, 3. And then you have to work out everything just in the first value. Once first value different, a different first value. So BA equals this. So the first value would have been this row and this column. So it's first element times first element, which is 1. And then second element times second one place. First element times first element. Second element times second element. 2 times 2. Plus 2 times 2 is 4. I don't have to work out these values. First values are already different from up here. I don't have to work out the rest of them. This is equal to 5, 0, 0, 0. And this is not equal to AB. So BA is not equal to AB. That confirms that it is not commutative. Alright, I'll get something different. Oh, I put in 0, my mistake. These are not zeros, you know. Wow, these are not 0. We just didn't work them out. I don't need to work them out. Once the first value different, they go, they're different. The first value there is different. Alright, so I don't work these out. So they're not zeros. My mistake. Just don't know, didn't work them out. Once the first value different, then they're not the same. I don't have to work out all of them to show that. The next one wants a to the minus 1. Alright, so a to the minus 1 is 1 over the a to the minus 1 equal 1 over the determinant of a times the adjoint of a. What is a again? A is 1, 1, 2, 3. So remember, a is 1, 1, 2, 3. Ready now? So it becomes 1 over the determinant is the first diagonal product minus the second diagonal product. First diagonal product is 1 times 3 is 3, minus second diagonal is 2 times 1 is 2. Times the adjoint. We do the adjoint again. Interchange the elements on the first diagonal, switch them around. So 1, 3 becomes 3, 1. They leave these two where they are and change the sign. So negative 1, 1 becomes negative 1 over here. And 2 becomes negative 2 down here. That's the answer right there. But this guy was still 5. Because this under here is a 1. So these come back and change. So it becomes 3 minus 1 minus 2 0. Minus 2 1. Sensor. That is it. Anything else? Yes, this one down here. This one down here says calculate the value of given that this is a matrix. Calculate the value or values of x for which the determinant is 0. This means that it's singular, you know. Singular. And has no inverse. Right? So the determinant is 0. Now when the determinant is 0 and the single, that means that this product equals this product. So it means that the AD product is equal to the BC product. AD product is this. 2x times 3 is 6x that equals the second diagonal product. The BC product is 2 times 9 is 18. If you divide both sides by 6, cancel away this one, you get 3. Or you could say take this 6 and divide it on this side. And we want to look at it, x equals 3. That's it. Alright, I'll stop it here for today, guys. About 1 hour of class we did. I'll stop it there for today. That's really more of the same. But tomorrow we start transformation. Alright, guys, so have a good rest of the day, everybody. I'm gonna send the video to the group, and you can watch over the video.
Interesting.
Redo the questions. Alright, good. Watch over the video, redo the questions. Alright? Okay. Bye, everybody. See you in class tomorrow on Monday. Bye.